Hello and welcome to the Wednesday, January 31st meeting of the Cluster API Working Group. Robert is out of town, so I'm going to be hosting the meeting today. I've been out the past few weeks because I've been relocating to Seattle, so I'm going to be counting on everyone in the group to kind of help self-drive this meeting. The first item in the agenda is following up from last week on a better folder structure. Can somebody speak to what we were working on last week and where we are with that?
So I think we're still in the process of the converting the CRD based the prototype code to the API server. So I think everything's still in progress. We agree will be one folder for the API type and one folder for client. And so let's see, wait for one more, maybe next week we can take a look where we are in terms of folder.
Okay, so just refactoring the API folder structure. Is there an open PR for that?
It's ongoing. Yeah.
Okay.
Yeah.
Cool. Okay. Next item. This is going to be short if nobody else adds agenda items today, by the way. Next item is almost work tracked as issues on kube deploy. Need to add priorities, milestones, alpha, and beta. Does somebody want to speak to that? Because I have some questions there too.
Oh yeah, I can speak to that. So we started, tracking all the different ideas and work items that we had, for an alpha and kind of beta launches for the cluster API. And I think we have most of the items tracked now in kube deploy. Not a lot of them, they don't have like details yet. But I kind of want to share with the broader community, so you guys can take a look, and if you have like any questions or any comments, anything that might be missed, we need to figure out how to actually label those, for the idea that I have in terms of milestones, and get feedback on that as well. But that's kind of I think most of the work is out there, so you can take a look. We're hopefully going to tag some of them as kind of a help wanted as well, things that might be kind of easy for people to help with.
Okay. As far as releases go, you have alpha and beta here. Are these alpha beta API versions, or are we actually entertaining the idea of releasing software? And if so, what does that look like?
I don't know how to answer that question.
Okay, that might be a question. Like I said, I've been out for a few weeks, so.
Right, yeah. So I think we should add that question as an open question there. Yeah.
Okay. Cool. And I think don't we have community standard labels that we should be using in GitHub as well?
Yeah, I believe so. I haven't actually, figured those out. If you have any suggestions there, otherwise I'll ask a team. Team has me actually tagging some of the issues for kubeadmin, as well, and I'll just kind of ping him and see what he suggests we should do.
Okay, I'm going to take those 2 action items for myself to follow up on before the next call. Cool. Moving on, the next agenda item is the machine API proposal. Looks like we have a pull request. Somebody want to jump in and speak to that?
The pull request is done. All the checks are there. The only thing that has to be done is for Jacob to remove, there was like a placeholder file for the implementation that needs to be removed. But I think right now nobody's actually working with it, so I'll suggest just to merge it and then remove that extra file in additional commit, more or less. Okay. So this is my suggestion for this topic. If there are any objections.
I have not looked at the PR, but I can look at it today. And if nobody else has any issues and it looks good, I think we could probably merge it. Cool. So I'll take a look at that. Does anybody else have anything they wanted to bring up, or even just give me like a quick overview of where we are and what we've been working on over the past few weeks?
If I may, I have a few questions for two guys about this machine deployment API.
Okay.
So basically, I was looking at your proposal, and it seems really quite nice at points, but I do not understand understand, how would do you consider putting in place updates in your scheme, or how do you view these general in place updates, and on what level it will happen? Because all your, in fact, first you are trying only to create and delete an instance and put it into the instance set, and there is a question how it will be behave. For example, if you want to move update instance in place and move between, I don't know, different machines or so. So there is higher level problem, or I don't know, maybe some consideration, maybe I do not understand everything. How would be the in-place update differ in your schema from the basic rolling updates that you were showing for last 2 weeks? I was wondering how it would more or less compare to these machines, this discussion which we were having talking last week.
Okay, I'm not sure I understand the question.
We had some of the recent discussions about in-place update, and I just want to kind of confirm what you're referring to, and also I don't answer the wrong thing. So we're talking about like updating properties on the, for example, on a machine, and then like how if that's going to actually require a recreation, or if we're going to be able to kind of update those in place. Is that what you mean?
Yes, because in my opinion, there is some operations which would require heavier operations on VMs, and some would not. And
right.
How you would fit into the proposal? Because there are only simple operations.
I think it's the implementation detail for a controller, particular implementation. Different controller could implement this. Right? From API standpoint, there's no difference. This is a create after delete, or it's in place after delete. So I don't think we should be thinking from API. API is basically describe what should be done, not how it can be done. And the in-place update is how, right? The how part is taken care by the controller. So I would imagine, if we look at our like current implementation for the GCP provider, for the node update, we are doing the delete after create after delete. But for the master, if you update update the control plan version on the master, we actually doing an in-place update for you. Because it's very difficult, let's say, to delete after create for master in our current implementation. So we actually do in-place update.
Yeah, that matches my discussion as well with Robbie. I think last week, that the API is mutable. Just kind of a summary: the API is mutable. The controller makes a call on whether it supports which properties will require in-place update or not. And it could just error out, just recreate, at the beginning, later, support in-place update. One thing that we didn't actually discuss is if we're going to have configuration options, like which ones we might, if you want to force, in-place update or not, if you prefer, do a different way. We didn't actually discuss how to do that yet. So at this point, it will become just like a controller choice. Later, it could be configured by the user as well.
You said mutable, right? Not immutable.
I said mutable. Yeah, mutable API. Yeah, the API is mutable.
Okay, cool. Thanks.
Thanks. I have one more follow-up question. It's maybe rather specific, because in this proposal there is a place for state code. So basically, all failures are detected, and as soon as detected, the machine goes into fail state. And I was wondering what was the rationale behind it, and why do you prefer this for example, some different field which would contain error in parallel to the intended state. So we simply save the intended state, which of course didn't happen, and put some error, and then, I don't know, out of healer, fix it up or whatever. So I do not understand maybe this specific decision that to override the intent specific by the user with some state called failed. Is it any, maybe someone could clarify it? Because in this proposal from guys from SIG, there was an idea that basically machines have some states, and one of state is failed. So I wonder whether this idea to go into the state which is different from preferred by this intended by the user would be would not hide something from the user that he intended the machine to be creating state failed, and only he can see that it failed. So, am I clear on it? Or?
I mean, I guess I'm like, I understand the concern about a machine going into failed state, but I'm confused on the concrete question you're asking.
I was wondering whether, because in this proposal there is an idea to put a separate failed state and not some separate field with errors. So this failed would override any intended user state. So user would see, when we try to create an instance and it fails, we see failure, but we do not see where it came from. And so basically we have it as a separate state, not as a phase of a state called creating, for example. And I was wondering whether there is special rationale behind it, or in this proposal, or not. Maybe because it was in this presentation that Martin gave 2 weeks ago.
So the question here is, when one of the CRDs goes into a status of failed, it's overwriting the user status of creating. I think I'm understanding this correctly.
As far as I looked at this Gardner proposal, it seems to me that it is so, and I wondering what was the rationale behind it.
Well, more or less, the idea is that, or is Harvey here? I think he's available, so he can pretty much explain.
Can we get the question in the doc, or somebody's going to answer?
Oh yeah. So, Harvey, can you? Oh yeah, we can.
Yeah. So what we actually tried to do was, so the rationale was that we wanted to have 2 layers of state. So one layer was machine state, and the second layer was machine phase, right? So we wanted to have minimum set of possibilities for the machine state, and we were expecting that the higher level controllers, like machine set, machine deployment, they would be a primary consumer for the machine state. So for example, if machine state is currently running, or machine state is in the failed state, or it's in the pending state, so machine set is something that would like to react on this part. But then on the second layer we have machine phase, which is more human readable. So it contains then a lot of different phases, which would be like, it's currently running, or it's currently available. The phase could be available, running, pending, it could be draining, and so on. So which is more for the human readable perspective. And what we really did was different machine phases were basically categorized for machine states. So for example, the machine phase called, let's say, pending, available, running, could all be combined and called a single machine state, which is a running, right? So that was the overall idea, that we had 2 layers, where lower layer was mainly intended for higher level machine controllers to be used, and the other layer of machine phase was for human readability. And on top of that, we had, in a similar way we have in Kubernetes, we had last operation concept. So we added a field called last operation, where the last operation was mentioning that whether the creation was happening, deletion was happening, or updation was happening. So eventually, when you open up your machine object, you will get to see that the last operation was create. The machine state was, it could be either in the pending or running, or the machine phase could be anywhere. It would be either in the available state or running phase, and so on. So that was the overall rationale of doing it that way.
Okay, thank you. That more or less answered my question.
Cool. Yeah, thank you very much for that. Okay, looks like somebody added another agenda item, so I'm going to move on unless anybody has anything else on that.
So this is also coming from last week. So the PR for the machine set has been up and running for almost 20 days, and I think I'm the only one that who commented on it. So if the community can just look at the proposal, see if it's okay. If they don't like something, just comment so we can move forward with it.
Yeah, I can follow up on that. Yeah, thank you.
That would be great. Henrik will also have a look at it tomorrow or this week. So fix the comment from Martin. If there are other things, would be great, and then we can fix this already.
Yeah, thank you for bringing that up. I actually had a similar question about these machine set being like, it's been going on for a while, so we need to get some traction.
Cool. So it looks like we're gonna have some people take a look at that PR. Does anybody have anything else they want to bring up, questions or agenda items?
So I had a sidetrack question. So I was looking over the cluster API, and I got to know that we have repairer, then we have upgrader. Those things are separate tools, right? We expect them to be running separately. So for example, a repairer would be running separately, or it will be a client-side tool, which will basically check the machine status anytime and repair the machines, right? But why could they not be part of the machine set itself? So in our case, when we implemented node controller manager, so in machine set, we implemented it in a way that whenever machine goes in an unhealthy state, right? So machine controller basically changes the machine state to failed. And that's where machine set gets to know that this machine is in the failed state. And after a certain timeout, it automatically replaces that machine with a healthy machine. So that auto repair part gets consumed in machine set. In a similar way, we have a client-side upgrader tool that's being proposed in cluster API. So that part went into the machine deployment, right? When we change the configuration of the machine deployment, the rolling update anyway does the upgrade for us. So I was just wondering, why do we have a separate tool?
The tooling, the upgrader, repair, that's we write those two for the KubeCon demo. So I think in the future there will be many different kind of controllers. Some will be like functionally very rich, like including all the like repair, like maybe auto repair, maybe scaling is inside the controller, right? Some of them will be like a very like concise, very thin layer, and all the rich functionality could be on the client side. So I think for the class API, just provide a choice for the different implementation. So in the end, the customer can choose deploy different things. Maybe in the corps, there will be like a lot of the functionality will be actually no client side, right? It don't want to like reach like a controller. You want the controller can deal with different cloud provider, right? And as corp, they can provide the unified like the front end, use the cloud class API to do all this scaling, repair, upgrade, all from the front end. So I think that's the reason why we write those two to demonstrate it's possible to using a common tool can work across different provider, different cloud provider, cloud or on-prem. I think that's the original idea.
And also, it seems like from conceptually, there are distinct things, different layers that they could be combined, of course, as you suggested, but not necessarily, right? So that's why I think we are kind of tackling like the lower layer first, and then like we should have a kind of also a better story on how we're going to go about upgrades or how we're going to suggest that people do upgrades or repair. But it seems like that's a kind of a higher level construct that can be built on top of the the lower layer of machine management there. I don't know if Chris has any thoughts, especially with your experience with KubeCon, about this. Does it make sense, like what Feng mentioned?
I would want to look at the API. I honestly haven't looked at it since before KubeCon. But originally, when Robbie and I were talking about this, we very much favored the idea of having simplistic building blocks, and then the controller would take that and then have custom controller logic that, like somebody mentioned earlier, would implement the how. So in the case of machine definitions, like I would always favor simplicity.
Does that answer your question, Hardik?
Yeah. So that's correct. So having a separate tool might help, but I was just wondering, for complete automation at some point backing in the auto repair kind of feature might be helpful. Scaling up, scaling down on auto repair right inside the machine set itself. But,
fully agree. Yeah, I agree. I think in the future there will be many different implementations.
Yes.
Yeah, different customer will have a different requirement, and yeah, so.
Yeah, ideally there would be a large population of controllers you could pick from, some of which are focused on things like resiliency of your nodes, and others that are maybe just focused on burst auto scaling and kind of don't care as much about the failures. So I think that's sort of like the design of the APIs, is flexible to support kind of whatever you need.
Yeah.
So I have a maybe non sequitur or dumb question or both. Is anyone aware of any current provisioners which are targeting the cluster API, which would allow direct manipulation of the cluster API to make changes? I guess what I'm thinking is, like, once you've stood up a cluster and you have these cluster API objects, is there any world where the user might decide to change the machine set definition and expect the controller to update the cluster to match?
Are you talking about manipulating a node or manipulating the cluster components themselves?
Well, define cluster components themselves.
Like the control plane, the API server.
Just the nodes. Well, potentially even the API server, though.
Right, because there's like two concerns here, right? There's like manipulating the nodes, which is a fairly straightforward process, and that can cover everything from failures to repair to upgrades. But then like upgrading the control plane itself is a little bit more of a complex issue to tackle. But yeah, I think one of the original ideas behind the API was if you wanted to, like, for instance, scale your set of nodes from 3 to 4, that would be a declaration first, and then the controller would implement that.
So I'm thinking specifically, so let's just take, to be concrete, Kubernetes. Kubernetes has a config file, right? And in a world where we had machine set definitions, if I updated the machine set out of band with updating the Kubernetes config, that might not work.
So I'm working on a PR right now into Kubernetes that's going to sort of take that configuration file and move that into the CRDs that we're talking about. So the configuration file is going to turn into this. They're not going to live in concert.
Awesome. Thank you.
Sure. I'll put a link in the doc to that PR so you can take a look at it too.
Appreciate it.
Cool. Any other questions or agenda items from anyone? Okay, awesome. Short call, everybody. So have a good day, and we'll see you next time.